Hello, and welcome to Chapter 1, Section 1. Today we're talking about analyzing categorical data. So we want to be able to look and compare data that's categorical. So in other words, not quantitative. We're focusing on categories. So if we were to give out a survey, the answers we would get back, the responses we would get back would be non-numerical answers. So like if I asked, what's your favorite color? You would answer back with a color, which is not a number. So we want to be able to display this data. Normally we would use a bar graph or a pie chart. Those are the most simple things that we can use. So if you want to remember, a bar graph is just like a histogram. We talked about a histogram a little bit already, but a bar graph, we got the rectangle bars. You want to make sure that in a bar graph there's spaces in between each bar. That's what makes it a bar graph, because a histogram is not allowed to have those spaces. So that's one big distinction that we want to make. And then a pie chart, you guys have seen a pie chart. I'm not really focused on how to make them. You should know that already. So those are the basic ones. We're not getting super into them just because they're basic. We want to get into the little bit more complicated stuff. So I'm going to start with an example where we actually have two different sets of data, two variables that we're looking at specifically. So in this example, we have a research company. They asked a random sample of 2024 adults, cell phone owners, to see what kind of cell phone that they owned, and they all lived in the US. So the results are shown in the table. It's separated by categories of the different cell phones that they could own, either iPhone, Android, or other. The other also included like non-smartphones, because old school. And then also separated the people by age groups. So even though the ages technically is a quantitative variable because ages are numbers, by separating them into categories like that, that makes it categorical. So here, this table actually has a name. This is called a two-way table. So in a two-way table, there's two ways to it because there's two different variables that we're looking at, the age group and the type of cell phone. So with those two different variables, we want to choose a different way to display it rather than a bar graph or a pie chart, because those will only display one of those variables at a time. And since we have two, we want to be a little bit more complex. So a two-way table is a nice way to organize your data, but it doesn't really help you compare anything, because visually a two-way table, all I see are a bunch of numbers here, and that's not super helpful for me. So with our two-way table, there's a couple things that I wanted to define. So first is the marginal distribution. Marginal distribution just talks about anything in the margins. So right here, anything in the margins is kind of like the totals for us. So those are the numbers that we want to look at or focus on when we're talking about overall, just looking at like how many total iPhone users are there, or how many total Android users are there, how many total 55 plus people are there. So that's something that we want to compare sometimes. Sometimes there's more. So the other thing that we want to look at, the other part of our two-way table, is all the numbers on the inside. So anything not included in the totals. Those are called our conditional distribution. So in my definition, I put that the marginal distribution and the conditional distribution can either be counts or percents. So when I mean counts, I'm just talking about the actual numbers that show up in the table, like how many people there are. Percents we can also calculate based on the total overall amount of people in the survey, or even just within each of the categories, the total of that category compared to the conditional distributions. So we can calculate percents that way, and it makes it a lot easier to compare, especially when the marginal distributions are different numbers for each category. So usually percents is just easier to make comparisons, and that's why we want to use them more often than not. So now that we have this data, we want to actually compare and see, is there some sort of relationship between these two variables, some sort of association? You might have heard this word before, maybe even correlation. we want to see if there's some sort of pattern or trend or relationship between these two variables to see if we can predict one from the other. So in this case, I'm probably looking to see if I knew someone's age, if I would be able to tell what or predict what kind of phone that they own, because that makes more sense. Otherwise, if I tried to go the other way, where if I knew what phone someone had, would I be able to predict their age? Sure, that probably is okay, but in real life, I don't know if that's very useful of information. Probably if I knew their age, what kind of phone would they buy or own is a little bit more useful, at least for marketing. So basically, we say that association exists if knowing the value of if we know the value of the explanatory variable, that's the x variable, helps predict the value of the response variable, and that's usually what we have on the y-axis. So now we're going to try to answer the question, is there an association between age group and type of phone owned? So we know our explanatory variable is going to be the age group because we're trying to use that to predict the type of phone owned, which would be our response variable. In order to do this, we're going to make some graphs because then we can actually look and compare. So the type of graphs that we want to make are not just the bar graph and the pie chart, because that only displays one variable at a time. We're actually going to make a side-by-side bar graph or a segmented bar graph. Both of those things will show multiple variables at a time. The first thing I'm going to do is to recreate the two-way table, but this time instead of using counts, I'm going to look at percentages because I want to be able to easily compare even though in each category I have a different total amount. So because we're using the age groups as the explanatory variable, I want to make sure that I compare within each age group what is the percentage of people who have the different types of phones. So in the 18 to 34 age group, there were 169 iPhone users. So with a total of 517 18 to 34-year-olds, I'm going to take 169 divided by the 517 total of that age group, and that'll give me the percent of the iPhone users within that age group. It ends up being 32.7%, so I'm going to do this same thing with the Android and the other categories as well. So in the next category, in the 35 to 54 age group, there were 637 people total, so we're going to divide each of those numbers in that category by 637. I've also gone ahead and completed the percents for the 55 plus age category. Same thing, since there were 870 people total, I just divided each of those conditional distributions with the 870. So now if we look at the totals, we can really only add up the totals of our percentages of our age groups, and each of those age groups, if we add vertically, should add up to 100. We might be off a little bit just because of rounding error, so sometimes if you end up rounding up too many times, you'll end up with like 100.1% or something like that. But usually we ignore those just because we know it's rounding error. At this point though, if you were to try to add up percents going horizontally, like if I added up all the percents for the iPhones, you would end up with like 74 point something, which doesn't really make sense because normally if we add up totals, you should get like 100%, right, when we're dealing with percents. But here it doesn't really make sense because our percentages aren't based off of iPhone users. They are based off of the categories of the age groups. So that's why we can't really total it up that way. And at this point, like, why do we need to total them anyways? We're not really looking to check just to see that it adds up to 100. With this information now, I'm going to start by making a side-by-side bar graph. So a side-by-side bar graph really is still a bar graph, but within each like bar that we have for each category, we're also going to have smaller bars within it to compare the other categories. So because we have the two variables, we want to have both in there. So in this question, we're asking, is there an association between age group and type of phone owned? So since our age group is our explanatory variable, I'm going to have that on our x-axis. So we'll start with the 18 to 34 age group. We have the 35 to 54 age group, and the 55 plus. I'm just going to give myself plenty of space because I do have the separate categories within it. On the y-axis, because we've converted all our numbers, our counts into percentages, we're going to have percents on the y-axis so that we can compare what percent of each category was, or how many people were in each category. So our fancy way of saying percents is relative frequency. Okay, so I'm just going to be real rough with this. We'll call this 50%. Or actually, let's change this around. I think our numbers are kind of smaller. So we'll call this 40% and 80%. Just roughing it here. Okay, so within the 18 to 34-year-olds, we have 32.7% are iPhone users. So I'm going to make a bar for them. And I'll use colors just because it's easier to label here. So red for iPhone users. And then 41.4% were Android users, so just a little bit more. Oops. Guys, it's really hard to draw on a computer. We'll use blue for them. And then other was 25.9%, estimating here. Okay. So I tried to keep my bars slightly separate. They were still in the 18 to 34 category, so they're close together that way, but there are little spaces between them. It's hard to see because my drawing skills awful. But that's the beginning of my side-by-side bar graph. I'm going to continue this for my other categories, my 35 to 54-year-olds and my 55 plus. Okay, so I've completed my side-by-side bar graph with all the percentages of the other age groups. And as you can see, with the older group, the 55 plus, it looks like they are most likely to use an other type of cell phone, so maybe a non-smartphone or something other than an iPhone or Android. In that case, it kind of makes sense. First of all, I'm going to preface this with, the study was done in 2013. And this is side note, a lot of our examples that we use, everything that you read about in your book, these all came from like actual studies. So there's a lot of citations within the textbook. And if you look in the back, there's this like entire section devoted to citations of all the different studies. And so it's really cool. That's why I like statistics, because everything has been done before and they can write about these now in textbooks and refer to them. So anyways, this is a little bit older of a study because 2013, but still, the older generation was more likely to use a non-smartphone rather than an iPhone or Android. And then with the younger groups, like the 18 to 34-year-olds, a lot more likely to use iPhone and Android. And that kind of decreases as people got older. But now it's a lot easier to see versus just in a two-way table. Another type of graph that we could make that'll display the same data is the segmented bar graph. So it's still a bar graph. It just, instead of having like 9 bars that we made in the side-by-side, it'll just have 3. But then within each bar, there's little sections for each of the categories. Okay, so here I've started the segmented bar graph. As you can see, on the x-axis, it's still the age groups. On the y-axis, it's still relative frequency, but this time it goes all the way up to 100. So a full bar would be like everyone in the 18 to 34 age group. So that's 100% of all those people. Same thing with the other age groups. And then we'll separate each of the bars by the categories. And we always want to go in order because it makes things easier to compare. So first, in the iPhone category of the 18 to 34-year-olds, there was 32.7% there. So we would mark up within the first bar about 32%. So this would be the iPhone users. I'm going to color that in because we were using red for them earlier. So there. And then for the Android users, there was 41.4%. So from that line that we just drew, we're going to add 41.4% 4%. So we end up about there. And then that means the rest of them for the other types of smartphones or other types of cell phones would be the rest. And then we would continue doing that for the other age groups as well. So with the 35 to 54-year-olds, 26%, and then add the 29.7% to that, about here. And then that means the rest of it would be the other. And then lastly, with the 55 plus group, we've got not that many iPhone users, even fewer Android users, and then a whole bunch of others. Okay, so again, it's basically the same information, just a different way to display it. So these are the types that we want to focus on when we have two variables at a time. Now that we have our graphs, the original question we were trying to answer was, is there an association between age group and type of phone owned? And looking at our graphs, it definitely looks like there is an association because as people were older, the older age groups, it looked like they were much more likely to own an other type of phone than the iPhones or Androids. So yes, there's an association. Let's say there was not an association, so no association between the two variables. If that were to happen, the segmented bar graph each of the bars would look about the same with each of the different categories and how they were split up. So if each of the different categories were about equal, that would show that there's not much difference between each of the categories, so there's not really a relationship between the two different variables that we were looking at. So that's what you would kind of be looking for. Same thing with the side-by-side bar graph. All right, that's it for this section.